So if we're going to solve a system of equations using substitution, we use this method in certain situations, right? We're not always going to use this method because graphing method is very effective, as is the elimination. Algebraically, I use elimination most of the time. I'm going to show you a few different situations where you could use substitution, but if you're given the option, you could also use elimination. Like you could see, you could just subtract these. But the basic idea behind substitution is that y is equal to one expression, 2x minus 7, but y is also equal to negative x plus 7. So instead of saying y, if I already know what y equals, I can just take that and substitute it in for y in the original expression, original equation. So I have negative x plus 8, and then just the rest of this first expression equals 2x minus 7. From here, I just solve for x like I normally would. 8 equals 3x minus 7. 15 equals 3x. Therefore, x equals 5. The nice thing about substitution is usually one of your variables is already solved for from the very beginning. So doing my final substitution to solve for y is just as easy as substituting in this value in an equation that's already solved. So I'm substituting and simplifying. Get 10 minus 7, or that y equals 3. That's a pretty straightforward example. If we look at a situation where they're not both in the form slope-intercept form, but only one of them is in slope-intercept form, we'd say that the second equation is solved for y, because y is by itself. So once again, 2x plus 3y equals 4, but I already know what y is. So I can substitute y in the equation above. So I get 2x plus 3, but now it's times what y is, x minus 1. And then, of course, that's equal to 4. Now I just simplify and solve. 2x I have to distribute here. 3x minus 3 equals 4. Combining like terms gives me 5x minus 3 equals 4. 5x equals 7. Therefore, x equals 7/5. Just because you got a fraction doesn't mean it's wrong. Let's go ahead and solve for y using the bottom equation, and then we'll just verify. Y equals, going to do my substitution, so 7/5 minus 1. 1 is just 5 over 5, so I can say y equals 7/5 minus 5 over 5, or 2/5. And now with my answers of y equals 2/5 and y equals 7/5, I can substitute them back into either equation and verify. Since I just used this one to solve for y, I'm going to want to use this one because if I made a mistake, I'll just catch it more easily. So 2 times x, which I accidentally wrote over, but you can see is 7/5, and then plus 3 times y, which was 2/5. Now the fractions might make you nervous, but checking to see if this does in fact equal 4 will tell us whether or not we did the process right. So I get 14 over 5 plus 6 over 5. Well, that's the same thing as 20/5, which of course is 4. Therefore, we know we've done the process correctly. So even if it's not both equations y equals and y equals, what you can do is you can substitute what y is into the original expression. And I'll show you one more example, which is a little more complex. Usually you're given the freedom to choose the best method to solve a system of equations. And this one where we have negative 5y and positive 5y, I would use elimination. But let's say that you wanted to do this using substitution. So you could choose one of the variables, either x or y, and then solve for it. I'll use this second equation and I'll solve for y, since that's what we've been doing in other questions. So I'm going to get negative 4x plus 21. Y equals negative 4/5 x plus, now I have to divide everything here. And this is where some people tend to make mistakes. But now that I know what y is, I can substitute that in for y in my original equation. So my original equation becomes 3x minus 5 times, and you're going to see this is quite cumbersome, which is why I would actually not use this method, but just to see how it works. There might be a scenario where you'd want to do that. I'm going to have 3x. And then minus 5 times a negative 4/5 is actually just a positive 4x. And minus 5 times a negative 21/5 actually just gives me, I'm sorry, negative 5 times a positive 21/5 just gives me a negative 21 equals negative 28. Combine like terms, simplify and solve. Adding 21 to both sides. X equals negative 1. Go back to our original problem, or really just any one of these that you want to go to, you can get the answer from. If I go to my original, I can solve for y just by doing my substitution. Negative 3 minus 5y equals negative 28. Negative 5y equals negative 25. Therefore, y equals positive 5. Same thing would have been true had I substituted into this equation or even this equation. Notice if I would have just said y equals negative 4/5, but instead of x, negative 1 plus 21/5. I get 4/5 plus 21/5, also known as 25/5, or 5. So any of those equations would work to solve and get your answer. It's just whichever one seems easiest to you. So if you're just looking at basic substitution, or if this is the first time that you've seen it, you can stop the video now. I'm just going to show a more advanced method. I said in a graphing video that systems of equations can be more complex. So imagine that I have a parabola, which is y equals x squared, and then I have the line y equals x plus 2. This is going to intersect my parabola in two different answers, and I could use my graphing method to find the solutions. I could also use elimination or substitution. So I'm going to show you substitution since this is the same video. With the same logic from before, if y is equal to x squared and y is equal to x plus 2, I can think of y as just x plus 2. And so I could rewrite my equation, x plus 2 equals x squared. Now, if you're foggy on how to solve quadratics or you've never seen it, just come back to this video after you're a little more familiar with it. Setting equal to 0 in order to solve it, and then I can factor, and I get x equal, or 0 equals, and then I can factor this into x minus 2 and x plus 1. Therefore, either x minus 2 equals 0 or x plus 1 equals 0. So I get two different solutions, x equals 2, x equals negative 1. It makes sense that we have two different solutions because we have two different intersections. So I'm going to have to find the y coordinate twice. I like to use the easier one always if I can, so I'm going to go back to my linear equation. So if x is 2, or when x is 2, then y is going to be equal to 2 plus 2, or just 4. So one of my solutions, or one of my points of intersection, is going to be 2, 4. And then if I look at my second point, or try to find my second point, it's when x is negative 1. So when x is equal to negative 1, y equals negative 1 plus 2, or y is just equal to 1. So then I also have this over here. And you notice that the substitution method was a really nice algebraic way to solve a pretty complex problem. We're trying to find where a line intersects with a parabola, but the math doesn't get too bad if you remember how to solve for a quadratic. This is true for any function. You can use substitution no matter how complex it gets, and indeed it's a skill that you'll use in coming courses.